Okay guys, welcome back. We just established that this is not factorable, x squared minus 12x plus 22. There are no two numbers that multiply to be 22 that add up to 12. So that means we have to do Pythagorean theorem, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So my a value is 1, my b value is negative 12, and my c value is 22. So it should be like a flashback back to Algebra 2a. So here we go. We got negative 12, so that would be positive 12 over negative 12 squared minus 4 times 1 times 22 over 2a, which would be 2 times 1. Right, out front, 12 stays as is, plus or minus. Now let's do the square root. That's 144, because negative 12 times negative 12 is positive 144. And I'm going to do 4 times 1, which is 4, times 22 is 88. All over 2. All right, we got to do the subtraction underneath the radical. 144 minus 88, which would be, let's see here, 56 over 2. Right, square root of 56. 4 goes into it, what, 14 times? Yep, so what I got here basically is square root of 4 is 2, and I have the square root of 14 down here yet. And then basically I divide all 3 of these by 2, so our final answer would be 6 plus or minus the square root of 14. And the square root of 14 cannot be broken down anymore. That would be it. Alright, so that was not an easy one there in number 9. Actually, that was very tough. It made you go back to quadratic formula here. Establish what a, b, and c are. Remember, this is the a value. The a is 1. This is the b value, which was negative 12. And this is your c value. Alright, let's go for 10. I'm going to subtract 3x squared over here, so I get 4x squared minus 8x, and I'm going to subtract this 1 from 5 to get positive 4. All these are divisible by 4. Okay, so I have x squared minus 2x plus 1. Well, after the last problem, this feels a lot more user-friendly. Okay, we still have that sign chart up there in the top left corner, minus plus. Okay, minus plus is right here, which would be minus minus. There's not a lot of numbers that multiply to be 1 and 1. The signs are the same, so we add them. Yeah, we got 2, so 2 matches up. So we can go ahead and put our 1s in. So this is called a perfect square, because they're both the same thing. X is equal to 1, x is equal to 1. It's also called a double root. Okay, so that one was a lot easier than 10. Give me a second to get set up here for the last two. Yeah, 9. 9 deserves a star. That was a tough. Right. Coming down here to your last set, and then we'll be finished with 7.6 day 2. Looks like 15 is larger, so I'm going to move the 14 over. So I'll have 1y squared, which means I'm going to add this 6y over. So that would be minus 1y, and then I'm going to add this 1 here to get minus 6. That's now 0. Remember, I subtracted this over. Okay? So, I have 0 equals, parentheses, because this is a 1y squared. Like x, I'm going to put my y's in. Minus minus is this last scenario in red, so I should have plus minus in parentheses. We're still breaking down the last number, 6. And you can see there's only 2 pairs of numbers. The signs are different in my answer, so let's take the difference of 1 and 6, which is 5, and the difference of 1. Looks like I'm looking for a difference of 1, so 2 and 3 are in. Let's take the larger number 3 and put it with this sign. So 3 goes with the minus sign, 2 goes with the plus. Now remember, 2 plus a negative 3 gives me that negative 1. 2 times negative 3 gives me that negative 6. That's the quick check you can do, so you know that you're correct. Now that trick only works when the leading coefficient is 1. This guy up here is 1. And I subtract 2 over, y is negative 2, and y is 3. All right, let's go to 12. 7's larger, so it looks like I'm moving everything to the right side. All right, so that would give me 1y squared. Subtract 4y over, that would be negative 11y. Add 1 over, I'll get positive 30. All right, so it looks like 1y squared makes it a nice 1 out in front, minus plus. Where's minus plus? Up here. All right, minus minus. And numbers that multiply to be 30. I think we did this earlier, so I'm just going to keep going here. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Signs are the same, so these will give me a sum of 11, 13, 17, and 31. We're looking for 11. So 5 and 6. So y minus 5 is equal to 0, and y minus 6 is equal to 0. That quick check still works up top there. And this one's 5. Now this check here is what I'm referring to. Negative 5 times negative 6 is 30. Negative 5 plus negative 6 is negative 11. So these are cool. So it looks like 9 was the only one that was really tough that wasn't factorable. You had to use quadratic. Good review. But most of them should be factorable. Now what's kind of cool about this is if you were to plug this in, or should I say more so, if you were to write this in on Desmos, the graph, the parabola, will hit at these values. Okay, so you might want to use x instead, all right? And then we'll hit at x equals 5, x equals 6. So you can check these graphically as well. All right? And what I'll do is I'll actually type that in for you. All right? So give me a second. I'm going to transfer this over to Desmos, and then we'll go from there. All right. As promised, here's Desmos. I typed in y squared minus 11y plus 30 as this x squared minus 11x plus 30. And you can see here it does hit, the parabola does hit on the x-axis at 6, 0 and 5, 0. Like I said, x equals 5, x equals 6. Notice I just changed my y's to x's. Hey guys, we'll see you in class, and thank you for watching the video. This was a long one, so take care. We'll see you soon.